Hi everyone, in this video we're going to cover the math principles for the SAT. So we're covering the principles for the math section of the SAT for both the calculator and non-calculator section. This video may also work for other exams such as the ACT or even the GMAT or the GRE, although there are some principles that apply almost exclusively to the SAT. So if you're taking another exam like the GMAT or the GRE, I advise you to go to the specific videos on those exams, which I will post after this. So if you're watching this and you don't see those videos yet on my channel, be patient, I'm going to post them. Okay, before we start, remember this is not a video for theory, okay? We're not going to cover theory here, we're only going to cover principles. And I do advise you to copy these principles in a notebook, even if you think they are pretty obvious or you think you may remember, I advise you to copy them down. Okay, so these are the 7 principles that I have chosen here. These are the principles that I think are the most important ones. So those are the ones that we're going to develop. So the first principle, you want to read and answer the specific question. We're going to focus on the specific. So you may think this is obvious because, of course, you want to answer the specific question. Of course, I'm going to read the specific question. What else am I going to answer? But if you think about it, most of the time, or actually most of the students, at least some time, made a mistake of not really reading the question. We jump straight to solving the problem or solving the question without really knowing what we're looking for. And this pretty much matches with principle number 2 of don't solve for X unless necessary. So maybe the question is not about X. Maybe the question is about 2X. Maybe the question is about X squared. Maybe the question is about X squared plus 1. So maybe we never really care about finding X. Maybe the question is X plus Y. Maybe the question is about Y. We don't know, right? So always look for the specific question and then solve accordingly. The third principle is to simplify. We want to make everything simpler than what it is. We want to work with small numbers, simple numbers, easy numbers. We want to factorize. The fourth principle is to factorize. Again, we want to work with a small expression, easy to manage expressions. The fifth principle is to not multiply or do any other operation unless necessary. The sixth is to look for restriction, and the seventh is to read the alternatives. Now we're going to develop each of these principles in depth. So we're going to go to principle number 1. Read and answer the specific question. Again, you may see the question, and the question may be about X, in which case we're good, we're fine, we're trying to solve X, but sometimes the question is not about X, sometimes it's about how many solutions. So they're not even asking you about X or Y or X plus Y. There's no question about the value of the variables. You just want some extra information, like how many solutions, or does it have any solutions, or what's the slope, right? So the question is not always looking for the variable, and this is important. That's why we want to read the question first. In another case, maybe it is about X, but not exactly X, but it's X plus 1. So maybe we didn't never care about finding X, because maybe we find X and then we have to add the 1. But if you notice, we can pretty much just find X plus 1 from the problem. So this leads us to the second principle, which is don't solve for X unless necessary. So we're going to use the last example that we use here, the X plus 1 equals to 2 over X plus 1. So yes, we could solve for X, but since the question is about X plus 1, and you notice that there's an X plus 1 and X plus 1 here, maybe we just should focus on that, right? So we're going to have X plus 1 times X plus 1, and that's going to be 2. So we have that X plus 1 squared is equal to 2. So X plus 1 equals square root of 2. So yes, X is the square root of 2 minus 1, but we don't really care about X because we care about X plus 1, and we already have X plus 1. Okay, so remember, don't solve for X if it's not necessary. Okay, the third principle is to simplify. We simplify because we want to work with simple, small numbers, okay? The simpler, the better. The smaller, the better. The lazier path is usually the best path. Okay, so how do we simplify? For example, if you have an addition, usually this happens in the calculator section. When you have an addition, you're pretty much tempted to just add them as it is. So you will be tempted to just add the 3 over 36 plus the 14 over 77. But actually what you want to do is you want to simplify these fractions to work with smaller fractions. So we're going to take the 3 out of here. We're going to have 3rd out of here. We're going to have 12. And then we have to take the 7th out of here and the 7th out of here. And now we work with smaller fractions. Now, this is important because, again, we don't really know what we're looking for yet, so it's always better to look with small numbers. Same thing here. Again, if you're in the calculator section, you may be tempted to just go ahead and multiply 36 times 19 and then the 95 times 16. But actually, what you want to do is you want to simplify those two expressions, and you want to simplify like this. You take 6, and then you take the 6 here and you get 11, and then you take the 19 here, so you get 1, and you get a 19 here and you get a 5, and that definitely is easier to multiply 6 times 1 and 5 times 11, right? Another case in which you want to simplify, let's say you have an equation, maybe a second degree equation, a third degree equation, what have you, and since you have a 0 on the other side, pretty much you can just simplify this expression too. So what I'm going to do is I'm going to take half, right? I'm going to take the factor 2 out of all the expressions. So I take it from here, and from here, and now I'll be working with 4x squared plus 2x plus 13 equals to 0, which you can see that it's easier to factorize than the previous equation, and it's exactly the same value, right? Another case in which you want to factorize, maybe when you're working with percentages, you have like 120% out of 2000. So maybe you'd be tempted to just multiply 120 times 2000. But actually, if you think about it, since this is 120 over 100 times 2000, all you want to do is just get rid of the zeros, and then you'll be working with smaller numbers. Okay. The next principle is to factorize. This principle is very similar to the previous principle. Remember, the goal here is to work with small numbers, simpler number, manageable numbers, okay? So again, let's have this as an example. By the way, all these examples are taken from official SAT tests. So, okay, so we have this. We have two functions, g of x, f of x and g of x, right? And then the question is, what is the division of this equal to? Now, when they give you this, remember the SAT does not really require you to perform division of polynomials the way they teach you in school. So they don't really have to, you don't really have to apply the Horner or Ruffini methods to divide polynomials. Yes, maybe this is something that you know. Maybe this is something that you're just seeing right now in school, or something that you really, really remember. And actually, most of the students, like I hate division of polynomials from school. So you don't have to do that, okay? You could, you will get the answer, but you don't have to. So what you will have to do here, so let's put what these expressions mean. So we have x cubed minus 9x over x squared minus 2x minus 3. You could divide this, okay? But maybe we can just factorize them, right? So how are we going to factorize? We're going to factorize the f of x, and we're going to factorize x. So we have x times x squared minus 9, and that over x squared minus 2x minus 3, which is pretty much x minus 3. Well, let's put it x plus 1. So x plus 1 times x minus 3. And then you can see that you can still factorize the expression in the parentheses here. So this is going to be equal to x times x plus 3 times x minus 3 over x plus 1 times x minus 3. And now we're going to use the previous principle of simplifying. I mean, why would I multiply this and go back to the original if I can just simplify it? I'm going to simplify the x minus 3 and the x minus 3 over here. And I'm going to be left with x times x plus 3 over x plus 1. I haven't put the alternatives here, but actually this is the answer. This is going to be an expression that is going to be shown in the answers. Okay, so if you notice, we just factorized first and then we could simplify. This is important because when you factorize, and most of the cases in the SAT, you're going to find that you factorize because the factorization is going to help you simplify. So pretty much we're combining principles together, right? We factorize because we want to simplify. And maybe just by looking at this, we wouldn't have thought of simplifying, right? And the more you practice with the SAT question types, you're going to see that you can spot that if you do something, like in this case, if you factorize, you're going to reach a simplification somewhere along the path. Okay, the fifth principle, do not multiply unless necessary. And it's actually not just not multiply, but just don't add, don't subtract, don't divide, or don't do whatever operation you're set up to do before you actually see whether you have to do it or not. Okay, this is very important. And again, this pretty much goes with the factorizing and simplifying thing. So let's say, do you want s? So they give you s equals 4, and they ask you what is the value of 20s minus 15s. So if you're in a rush, you may feel the need to just replace s, right? So you're going to say, okay, s is 4, so I'm going to replace 20 times 4, which is 80, and s is 4, so I'm going to replace 15 times 4, which is 60, and so I'm going to have 80 minus 60, this is 20, which will get you the answer. And yes, it's not going to take you that long, but it's simpler to say, okay, if I have 20s minus 15s, then I have 5s. And since s is 4, maybe this is just 5 times 4, which is 20, which is much simpler and easier. Another thing you may find here, like they are going to give you an expression here, right? So before starting doing anything, like before even factorizing, you want to put everything back into their place. So better to just take the 2x to this original place and the 1 to original place, and then factorize. Or maybe here too, they say the function is defined by x squared minus 5x minus plus 6. Maybe you're tempted to just replace the 4, input the 4, and just kind of operate it. But maybe you can just, well, in this case it's 4, so it's not that bad. But maybe you can just factorize first. So you want to factor it like this is like x minus 2 times x minus 3. So if instead of 4, this were an 8, then it's definitely easier to, or even that's like even a 10, it's definitely easier to work with this than to like square, multiply, and then replace with every single instance of the x. The sixth principle is to look for restrictions. Restrictions are all over the place in the SAT and actually in the other exams too. So basically we have two types of restrictions. We have expressed like explicit restrictions and implicit restrictions. So explicit restrictions are literally restrictions that are going to be provided in the problem. So let's say x is different than -2. So you know that there's a restriction, like x cannot take this value. And actually in a previous question that we have done before, we also had a restriction, I didn't copy. So when they say that x is bigger than number 3, there's a restriction, which means x cannot be less than 3. Right? It cannot be equal than 3, actually. It cannot be equal or less than 3. So you are given restrictions all the time. Okay. You can also have implicit restrictions, which means they're not literally telling you, hey, x has to be bigger than 3 or x has to be different from -2. They're giving you other types of restrictions in the body of the problem. For example, here, they're telling you that this is the number of space shuttle launches. So when they tell you this, when they give you the number of an event happening, then what is the restriction here? The restriction here is that whatever this number is, okay, has to be both positive and it has to be an integer, okay? So why? Because it's a number of space shuttle launches. So you cannot have 1.5 launches and you cannot have -2 launches, right? And every time they give you a word problem, you're going to kind of start noticing the restrictions. These are important in some problems more than others. For example, here, they're asking you what is the total number of students, right? So every time they're dealing with humans or with any objects that usually do not separate into pieces, you know that the number of students has to be both positive and integer. Okay, the same thing happens with time. For example, we don't have negative time, although we may have fractions as a unit of time. So always look for the restrictions. Okay, sometimes they're implicit, sometimes they're explicit. Okay, and the seventh principle, read the alternatives. Always read the alternatives, both in the calculator and the non-calculator section. Always read the alternatives. Why? Because the alternatives will tell you what type of answer you're looking for. So for example, here, they tell you which of the following is an equation of the line in the xy plane with the points 1.3 and 5,15. So you may start struggling hard to get the equation, but if you look at the alternatives, in this case, for example, they all have a different slope, right? All the alternatives have a different slope, which means maybe I don't have to find the equation. Maybe I'll just have to find the slope. And that will make my life easier because finding the equation will definitely take me longer than just finding the slope. So once you just read the alternatives, you know what you're looking for and you know how to solve it in the easiest, faster way. There's another thing here. Just let go of any idea of the fact that they may care about your extra knowledge. They don't. All they care is that you answer the correct answer, right? That you choose the correct answer. So even if you are not using a lot of knowledge and you're just using a principle and you're just using the alternatives in order to find that answer, just do it. As long as you get it right, that's it. That's your goal. Okay, so things to remember. I want you to remember that it's better going wrong than blank. This is another important thing. I didn't put it as a principle. This pretty much follows for every single section, not just for the math section. So do not leave unanswered questions, okay? What you want to do is you always want to provide an answer for every single question. You want to guess if it's necessary. You want to narrow down your options. So let's say now I know it's not A, I know it's not B, and in between C and D, so I have narrowed down, I have a 50-50 chance, but I'm running out of time, so just flip a coin and guess. Okay, and this is very important. I don't want you to get attached to any questions, don't get attached to any solutions. So it's better to just learn to let go and move on than just to linger for 2 minutes or 3 minutes on a question and then maybe not even getting it right, and then you will be wasting time that is valuable time because you have to use that time for the other questions. Okay, that's it for the principles for the math section. In this channel, I won't be covering all the theory. Remember, you can get all the theory from Khan Academy or other sources. So pretty much, I'm just going to be covering the strategies and tips for solving the exam. If you have any questions, leave them in the comments. Please remember to like, share, and subscribe, and we'll see each other in the next video. Bye.